Hey guys, welcome back to CMTEQ channel. In this part 2 of the tutorial, we're going to finally write the piece of code that will be sending or transmitting data from our SD controller here into the computer via the virtual serial port. Now, to begin with, I would like just to write a few comments here so that we can know what's going on here. So this is the SysTick timer initialization. So this is a SysTick timer initialization function, right? And this is obviously, we know it's the GPIO configuration, and this is a USART2 parameters that we just wrote here. Now we can go ahead and call the UART transmit function so that we can pass the message in which we want to transmit, because now we know all the settings have already been written. We've already also initialized the low level hardware settings in this msp.c file. So the only thing left here is to transmit. So in order to transmit, all we have to do is to come into the source file here for our drivers, right? Find this har_uart.c, expand this file, and in here you just need to look for the transmit function for your UART. So just look for the transmit function. It should be somewhere in here. You can see there it is. So if I double click on this function, look at it, there it is. Here is a function. So what I'm going to do is I'm just going to copy this function like this. And notice that this function also have the HAL_status type def. If we click on it, we're going to see exactly the same return that we had with this function here, the one that we are actually initializing the serial port. So I'm going to go ahead and just paste this here. Now you're going to see that it's going to give some errors here because the data in here are not exactly what it should be. But this is just specifying to us a type of parameters that it is expecting, right? So that you do not make mistake, then you have to fill in on every one of these parameters exactly what is expected from you. Now the first parameter into this function here is a UART_handle type def, and it's a pointer parameter. If we go into the function, we're going to see some parameters where they are actually describing. So it's a UART handle. Now the UART handle type def parameter is the same one here that we actually define here, that we are accessing the structures, right? These structures here that got actually all the settings that we are writing into our parameters, and we gave it a name USART2 so that we could access all these settings here. So what we're going to do is just to copy that and paste it here, right? So we're just going to paste it here. Then because it is a pointer variable, so we need to reference it with the %. So now what I'm going to do here is I'm just going to copy like this and just comment this line, right? And paste this in here. And then remove all of these other parameters like this, right? Now this is the first variable that we already replaced. Now we know that the next one is this p data, which is also a pointer variables. Now if we go into the transmit function again here, we're going to see that p data here is a pointer to data buffer. That means it's a message, right? To confirm that, you can see here they are checking if p data is null, right? If it's equal to 0 and also the size is equal to 0, then it's going to return an error. And these error messages are located into the HAL_status type def. If we may just go in there, we're going to see all of these messages are listed here as per what the transmission encounter. Now we can go back into the main function. We know that we need to pass a variable of type pointer here for our message. The variable is uint8_t pointer. So we're going to cast the message pointer here, right? And I'm going to call this message, the variable that's going to hold my message, as msg. So that's the message I want to pass, MSG. So now what I have to do to come here and declare a character variable of type pointer also, which is going to be holding this message here. So I'm going to say char pointer MSG is equal to, then I need to pass my message in between the double quotes. So I'm going to say, please like, share, and subscribe to CMTEQ. Then I'm just going to pass the end of line and new line, like that. Now I can go to the next variable here, which is the size of the message that you are sending. So I'm just going to place my comma again. I'm basically just going to copy this here and paste it right under my message, right? And then I'm going to say, because it is a variable of type unsigned integer 16-bit, so I'm just going to name it MSG size, and I'll initialize it to be equal to 0. Now the size of this variable will depend on the size of your message, and that's going to be passed into this variable there. So I'm gonna just come here and just say MSG size, like that. Now we can go to the last parameter here. The last parameter here is a timeout, because when you are transmitting, you need a timeout, because it's going to try to transmit in case there is something on the way. It will try to transmit a few times, and after which, if there's still no success, it need to time out and wait again for the next instruction. So you have to include the timeout. Now the timeout that we're going to include here in our transmission, we can get it into this header file here, _def on the define. Now here we can see that we've got this error message here and the busy and the timeout. So if we look right here, not even going far, we can see that we got the HAL max delay. Now this max delay is a large variable, so that is a maximum delay we can get for the timeout. So we can just copy that. If we want to specify a shorter timeout, we can also define it, assuming that it remain a 32-bit size integer that we can pass there as a variable for the delay. So let's go ahead, just copy the HAL _max delay and paste it in here on the timeout. So I'm just gonna paste it like that. Now you can see now the function is happy and we are actually done with all the parameters. So I'll just chop that one out. And if you want to include a shorter time delay and want to replace this max time delay variable, you can just go ahead and copy this variable and rename this to a 32-bit and just give it a different name and say time delay, right? Time delay, and you have to pass a large number here, so we can say 500 for instance. So we say 500. We know 500 is definitely less than this value here, which is in hexadecimal. So then you can just go ahead and copy this in here and your program is still going to work, but you must just take note that you're going to have a shorter time delay or timeout. So if you do not want that, you can just keep it as is. All right, now the next thing to do now here is basically, because this function also return a status message just like this one here, we just have to place it also inside an if statement, just as we've done on the other side. So I'm just going to put everything inside an if statement, right? And this is now going to be the result. So I'm checking if HAL is not okay, right? If HAL is not okay, then we want to be able to return and handle the error, right? All right, now we can go ahead and test our serial communication and see if we'll be able to send the please like, share, and subscribe to CMTEQ channel into our computer using the Tera Term program. But before we can do that, I we need to handle something here in case this function does not return a HAL okay. If it's not okay, then this condition will be true, then we should be able to handle it inside here. So to do that, I think I'm going to call the error handler function as well. So I will paste the error handler function there. But the issue I'm having with this error handler function is it will only toggle once and get out. So basically, the LED will probably just not blink or stays off. So we have to create some form of a for loop here so that we can at least blink a few times. So I'm going to just create a for loop here, and I'm going to say for j is equal to 0, right? Then I'm gonna say j is less than 10, right? And then I want to increment j. Okay, so then I will come, then inside here, this is where I want to execute my toggle, right? And delay for 1 second. So this means I'm going to just toggle 10 times until this is no longer true. So what it will create like a blinking. So I'm going to now change this to about 500 milliseconds so that it can blink very fast, right? So yeah, then we'll be able to see, okay, that's the error, right? And now after executing here, the function will then jump into the while loop where it will stay forever. So this will only execute 1 time and come out. So for me to get it again, if the error persists, then I have to press the reset button and come back again. Now what do we do inside the while loop? I'm just going to copy the same line of code, right, which I already have here. And then this time around, I'm gonna put a delay of, let's say 1.5, right? So that 1.5 seconds, so that we can see the difference between when it's gonna be inside the while loop and when it will be blinking for an error, in case there is an error, right? Now let's go ahead and write this code in and see if we can start testing. Okay, we've got an error here. What is it? J and declare first use. Okay, well, that's it. So you have to always initialize your variable. So let's say int j, we can always initialize it to be equal to 0 from the start there. So that's fine. Otherwise, you can't just drop things and start using them. They have to come from somewhere. So now let's build again. Hopefully there won't be no more error now. All right, there are no errors. He's happy. Now we can go ahead, and the debugger should now load the program into our board. Okay, waiting for debugger. It is loading. It is loading. We can see that the program is blinking. Okay, so it's actually blinking at a rate of 1.5 seconds, right? So let's see. That means we've already came out of there, right? In case there was a transmission. Now to test your board, you have to open Tera Term and move to serial. And from the drop down, you're going to choose the ST microelectronic ST-Link virtual COM port. So it's COM7 for me, and then I'm gonna say okay. Now when this window open, you still have to do further configuration, because if I reset now, I'm still not going to get anything here, because you have to look at the baud rate here. I specify 115/200 baud rate, so I have to come on setup serial and change the baud rate here so that it can fit the correct baud rate. Now if everything is as you have specified them here, right, then you can say new settings, and now you should be able to transmit the data upon reset. Because remember, when the program start, we first went in here, we sent a message. If there was an error, we went through the error handler, and then we came into our while loop here. This is why this LED is blinking at a rate of 1.5 seconds, because we are now inside the while loop. So I have to press reset so that I can start the program from start and do all of this and see if we can get a message. So I'll press reset, and there is nothing. Something is wrong here. Okay, we've got a problem here. We are not sending, but is it blinking? Okay, look there. You see the blinking rate have actually changed there. So if you can actually notice it, so when I press reset, it's blinking much faster, right? And after blinking much faster, then it goes to a 1.5 second blinking rate. So I'm going to just change the blinking rate again so we can see it properly. So what I'm gonna do here, I'll put it 300 milliseconds and then load again. All right, now we can test again. Okay, the settings remain the same, right? We still got our COM port, so the setting remain the same. Now we're still blinking at the same rate, 1.5 seconds. That means there's still an error there, so I will reset. Now you see it's blinking faster, right? 10 times and then there is an error. So this is working, but we are not transmitting, which means there is an error. So now what I'm going to do here is I'm going to try to debug. So now we need to find out why we are not getting HAL OK, right? If we are not getting HAL OK, that means we are getting HAL error or busy or timeout. We're getting one of those. Now let's try to debug this program. And I'm going to place a breakpoint here. Yes, okay, we place a breakpoint and let's rather go into debug mode. So I'm gonna start debug mode. And now we will try to step into this line of code. And when we step into this line of code, we actually gonna go inside this HAL transmit function and see. So just say switch so that we can actually see what is this function getting. So now it seems like we are now entering the debug mode. Let's wait. Okay, so now we are inside debug mode and we are now standing here at the initialization. So what I'm gonna do here, I'm gonna step over because I don't want to go in the initialization there, so I'll just step over it. Right, so now we are inside the GPIO-A configuration, so we're going to execute this function and I want to step over it as well. Now we going to do the USART2 config. Let's also step over that. Now we come here, this is where the problem is. Now here I want to step into this function. Or if you do not want to step into this function, what you can also do is to put these parameters here. Like one of them will be let's say message or MSG size. You can put them into here. So let's maybe put MSG size into the expression and hit OK. So you can see that MSG size is unsigned integer 16-bit and the value is 0. Now let's put MSG as well. So that's a pointer variable and you can see it's a character pointer variable. Now we can see what is the value there. There it is. So we've got a message that is there and the message is indeed please subscribe to CMTEQ channel right there. So that's a message, but the size is 0. Now let's step into the function now and see what's going on. So I'm gonna step in there and let's go inside the function. All right, now we are inside the function. Here we are, and the function is going to first check this if statement here. So what is this if statement is going to evaluate? So let's step into. Okay, something is happening here. Okay, so this if statement actually evaluated true, right? So the if statement evaluated true. Now we are now inside this if statement here. Now in this if statement, you remember when I was talking about the pointer data, if it is equal to null or the size is also equal to 0, then it will give an error. Now we can clearly see here the size, the message size is the value is 0, but the message itself, which is the P data here, there is a value. but this is an or statement, so it's either this is true or this is true, right? So this is false, but this is true because the size is 0, so obviously we're going to return an error. Now let's just execute and see. Now you can see the if statement have evaluated to true, right? You can see it's true. It's give a value of 1, so which means it is true. And thus give a value of 0, right? The value is 0. This is equal to null. Value is 0 because it's false, because this is not 0. This is not null. There is a message. It's not null. There is a message there. But this is indeed equal to 0 because the size here indicate clearly it is equal to 0. That is why we are now coming in here, so we cannot transmit. So now we know what is our problem. So let's just step out of this, right? So when we step out, let's step out and go back. Right, now we come back here, we do the error handler. And in the error handler, this is exactly where we're going to now go into the for loop here, where we're going to flash a LED very quick, right? 10 times. So we go into the toggle function, we flash the LED, we delay, and so forth. So that's why we're seeing that delay. So we know what is our problem, right? So I'm going to stop the debugging. All right, the debugging is now stopped. Let me just close that source file that just got open and see if we can fix the problem. Why is the message size 0? Well, here it is. It is equal to 0. That is why it's 0. So we actually not getting the size of the message. We're just getting that initialization variable. So we have to get the size of this message. So in order to get the size of the message, that's the one line of code that we missed there. We have to call a function, right? That is a C function that is going to get the length of this string, because this is a character string. So to do that, I'm just going to say msg size is equal to strlen. Now strlen stands for string length. Now inside this function here, I'm now going to pass, right? What am I going to pass? You guessed it, I'm going to pass this message here, the pointer variable to the message. So I'm gonna just pass it in there. So which means the string length is going to evaluate the length of this message here and return the size and assign it to the message size, right? So then the message size is now going to get a real value, and that function that we were just looking at is not going to evaluate to true anymore, so that it can return an error. So we will be good. So then we should be able to transmit the message. So let's try this again one more time, but let's rebuild first. I'm going to just rebuild quickly here. Okay, we're getting a warning here. What's happening again? Yeah, there are 2 warnings, but there are no errors, right? Let's look at the warning. Implicit declaration of string length. Implicit declaration. Okay. Well, it says here include string. Okay, so we actually need to include this header file, the string.h header file. So what I'm gonna do is I'm gonna come into the main header file here, and I'm going to include another header file. Include. So I'm gonna say string.h. Okay, like that. Now let's try to rebuild it again and see if that error is gonna go away. I mean the warning. Let's see if the warning will go away rather. Okay, the warning is gone, so the code is now happy. Now I'm going to go ahead and load it. Okay, we're not debugging anymore. Let me just close it. We basically just loading, but we're waiting for the debugger to connect. Okay, he's connecting. All right, he's done connecting. Is he done connecting? All right, cool. Okay, now what is happening here? we are flashing. We're flashing at that 1.5 second rate. Now if I press reset, you see we're not flashing fast anymore. It seems like we're not getting an error anymore. We're not coming into that for loop anymore that flashed the LED fast as we saw when we tried the debug. So now let's open Tera Term again. Look here. We already have messages here. Please like, share, and subscribe to CMTEQ. So the messages are already there. Now let's reset and see if it's gonna pop up. So congratulations, it seems like our serial communication is working. Now let's try to just increase the font here if we can. So come to font, right, so that we can just increase the size of what we are printing there, and maybe go to 14, right? Okay, now you can see it is much bigger, right? So now if we press, we can see please like, share, and subscribe to CMTEQ channel, right? So we can actually clear, right? So we can clear the screen, and we hit please like, share, and subscribe to CMTEQ channel. So it is indeed working, and clearly you can see we're not getting that faster blinking anymore, that the error was coming. Now we are happy. Now if we go and try to debug, you can see we won't come in there. So congratulations guys, thanks for watching and keep practicing. And yes indeed, if you find this tutorial useful, please like, share, and subscribe to CMTEQ channel. Until next time, stay tuned for more tutorial like this. Cheers.